Okay, so
Third grade.
section 5 is exponential and logarithmic models, and we're going to use models to solve problems. And for the most part, we're just going to be understanding what the models are, how to plug some numbers in and find unknowns, and to do word problems, which I know you all love.
Yeah,
The word problems.
are so much fun.
Okay. So, there's 5 different models. The first one is the exponential growth model.
Where's that?
It's up on the board. Exponential growth model. Y equals A times e to the power b times x, where b is positive. A and b are just constants. If there's any numbers. X is your variable. It's your independent variable. Your y is your dependent variable. And e is just a number. Okay? And so you can model how things grow by using this formula. And you get a graph, when you graph it, your exponential model, that looks, you know, what we did before when we did our exponential function. It's going to look like that. And so when you get a scatter plot that looks like that, you can use the exponential growth model to find some different information. All right. Now the exponential decay model is really the same thing, only you have a negative b. Okay, and so you have a negative b, and this will be used when you have models where things are decaying or losing over time. So, for example, you could use the exponential growth model to model the increase in goldfish in a particular pond. If they were reproducing at an exponential rate, you could use that model to figure out how many goldfish you would have in a certain period of time in the future. For an exponential decay model, you might, and I think that actually bald eagles are back on the rise now, but for a long time, bald eagles were on the endangered species list. There was less and less every year. We were losing them exponentially because people would hunt them for their feathers and to stuff them and all the crazy things people do. And so, for a long time, ecologists used the exponential decay model to model how many bald eagles would be left 20 years from now, 30 years from now. And these models obviously change. So again, you got to remember that as we change variables in there, like protecting them and doing different things, the models change. But at one point, that's how they determined how many we would have. And that's how they determined whether they put animals on the endangered or threatened species list, is by doing these models and determining how many we're going to have a certain period down the road. All right. The Gaussian model is used mostly in statistics and probability. It's the bell curve, and you've seen that probably before in different probability and statistics classes. And we use this typically, well, over the weekend when I graded the Algebra 1 tests. The Algebra 1 students, as a whole, didn't do great on the exam. So you've heard the term before, grading on the curve? Well, that's what this means. You know, we basically took a standard deviation of how many students should be around average and then readjusted the grades so that they represented a proportion of how much they had learned, not necessarily the number of correct or incorrect. So this is used for a lot of other things. They do it to validate tests. So when the SAT writers create a test, they do models first where they give the test to people where it doesn't count, and they make sure that a certain percentage of people are in a certain ranges and they fall within certain ranges. And if they do and it conforms, then they say this test is good to administer now. And once in a while they'll get one that's not. It's out of whack. Too many people score high, too many people score low, and then they'll throw it out and rechange questions and things like that. And then last but not least are these logarithmic models, and there's 2 of them because we have 2 different kinds of logs. We have the natural log and the common log. And so the natural log, and it's going to look like that, and then your common log is going to be much more stretched vertically. Okay? And so depending on what sort of models or what sort of data we have, you may use a logarithmic model. And so again, when you're looking at your scatter plots, that's what you're looking at. Well, we already know about the linear models. and we know about the quadratic models. And so now we're looking to see, does our scatter plot, what model would be the best to use, okay? And we're going to actually make models in the next section, not in this one. So this one we're just going to be using these to solve some problems.
Oh.
For example, an exponential growth model for world population in millions is given by P for population equals 5344 e to the decimal point 0.012744 t, where t represents years and t equals 5. We're doing this between 5 and 14. It tells you that t equals 5 represents 1995. So you have 1995 to 2004, I guess, is your years here where this model is applicable. And so if you wanted to know what the world population would be at any particular given time between 1995 and 2004, and these were inclusive, but I didn't have a little spot to make the inclusive line. Those are inclusive. If you wanted to find out what the population would be, or to make a prediction of what the population would be anywhere in between those years, 1995 to 2004, you would use this model. And so we'll use that to see when will the world population reach 6.8 billion. So what would you do, Ben?
Plug 6.8 for the P.
Okay.
Yeah.
No, you're kind of right, but you got to be careful with your 6.8 because you got to look at your units, what you're using here. Notice here the exponential growth coefficient in millions. So this is your formula in millions. So you have to put you have to start by putting 6.8 billion in millions. Well, how many billions is that?
68,000.
Well, I don't know. I'd have to look. So I still do it like this. So 6.8 billion over 1 equals, and how many billion are in a million? Don't you convert units this way? You just do them in your head and kind of try to figure it out?
Yeah.
All right, well, how many millions are in 1 billion? 100, right? And so 680, right?
But I thought you put the zero in.
6,800.
Yeah.
Darn, I was close.
Okay.
So 68,000 is the same. No, it's
And
not. Just kidding.
No, it's not.
Hold up. Not
Yeah.
kidding.
what's that?
6,800.
Nothing. I got it. Don't worry.
We're moving along.
6,800 is what I was thinking of.
So now you're sort of right, Ben, because now you want to do that. But you just want to make sure you have that, because if you didn't have this, then you did a lot of work for nothing. So your P is 6,800 equals 5344 e to the point 0.012744 t. And we're still looking for when, so we're looking for our t. So now what will we do? Divide.
344.
Okay. So 6,800 divided by 5344 equals e to the point 0.012744 t. Okay. And what, Ben? Okay.
Put it L N. No. Yes. Ln of that. Ln E. Yes, so you're left with that. Yep. You read my mind.
Oh, wonderful like that. And if I divided this whole thing by 0.012744, I'd be left with t, right? And so you can throw that into a calculator.
Oh boy. And we did something wrong.
18. Wow, okay, 19.
You got 19? What? What did I do wrong?
You did the
I
L
got-
line and then you divided it.
I got
You had
t equals 18.9.
Yeah.
You guys are right. You were messed up.
Okay. And so t equals 18.9.
No, don't do that. Yep, I got it.
So the question is, when will the world population reach 6.8 billion?
In 2009.
Be careful.
2008.
2008.
No.
Yes.
Yeah, but it's like at the end of 2000.
Well, but if we're around now, if you're telling 2013, would we say, do you round time and say we're in 2014 because we're past July? Until you actually hit 2014, even if you're at 18.9999, right? But it said to.
You're literally hours away from 2000.
Well, I mean, you think about it. If your birthday is tonight at midnight, if tomorrow's your birthday, tonight at midnight, you turn that time. Tonight at 9 o'clock, you don't say you're whatever years older. You don't actually turn that until then, even though rounding you're closer to that than the other. That makes sense, right? So with time, you don't. That's important. With time, we don't
Well,
ever.
then why is it like I was born at 9:15 a.m. So when I wake up in the morning and I say I'm 17 now,
Yeah.
but it's 6 a.m. Am I lying?
Yeah,
Well-
we're lying to ourselves.
Because we have to be technical.
Well, we're being common sense, yeah. I mean, technically, you were. I've always thought that it's sort of funny when they say years old because you were actually alive before you were born from your mother, right? Because we were alive in the
Isn't that
womb.
why
But we
Koreans
don't-
are, like,
But now the world does not use that time as real time, so, or the time of the day.
And that was.
Koreans do that though. That's why
Yeah.
they're older.
So they're
They
older.
I didn't
start
know
when
that.
you're conceived. Yeah.
I didn't know that. Okay,
Oh, you never knew that?
I did not know
That's why when they say, well, in America, I'm however old, but in Korea.
that. Okay. All right. This next one says, in a research experiment, a population of fruit flies is increasing according to the law of exponential growth. After 2 days, there are 100 flies, and after 4 days, there are 300 flies. How many flies will there be after 5 days?
It's like the double R in Spanish.
I can't roll my R's.
I can't either.
can't do it.
I never will be.
And so Mrs. Luce says she
Okay.
can't teach anybody.
No.
To roll your R's?
Yeah,
No.
I can't do
Like
I
that?
can't do it.
No.
She said she'd teach me. Never happened.
Do you guys both think Spanish?
Yeah.
I'm in
Oh.
Spanish 3.
Wait, I could start teaching calculus in Spanish. Would that be
Nope.
easier to help you with
No,
Spanish and calculus
no,
at the same time?
don't you do that.
How about French? We could do it in French.
That would be
Ooh,
even
I took French.
Répétez s'il vous plaît, chantez, c'est
No, you need to stop.
Oh,
You need to stop right now.
Yes. I learned 6 languages by the time I was 12.
Are you
What?
This
serious?
is sort of my hobby. Is I
Please
learn
tell me you're
languages.
joking.
No, Greek, Latin, English, German, French, and Spanish.
Oh my
I
gosh.
thought that would be interesting to do that. So,
Were you
No wonder you
going
were
to-
at
in a no, I wasn't home in school. In a research experiment, population of fruit flies. So what are we gonna do?
I don't know.
Well, that's repulsive. For
I'm-
one thing, this is a really gross example.
I'm
Fruit
just
flies.
shocked.
You ever do that? You take your peach pit and you throw it in the garbage next to your bed, and the next day there's like 25 fruit flies swarming around your bed.
Oh.
That happens to me, so I can't
My family
You do
my
that?
wife doesn't allow me to have
fruit,
eat fruit in my bedroom anymore.
Do you just do mathematical examples? Is that why you're not allowed? Because your family's scared
No,
of what you're gonna do?
no, they're afraid of the fruit flies if I eat fruit in the bed, though. Let's see.
Why
Alright.
did you do this?
I did. I put a peach pit next to my garbage, next to my nightstand, and next to it was like 100 fruit flies. So I had to clean the whole room out. I didn't realize that,
Oh,
I don't know where the first fruit fly comes from. That's the
Oh.
weird part. Like, where does the first fruit fly come from? So they don't just spontaneously generate. Anyway, how are we going to solve the problem?
You know, I have no idea.
You know I have no idea. I don't know why you're asking me.
Well-
Wait, let me think of a formula we could use. Can I start there?
Well, you already have a formula because I gave it to you, didn't
What
I?
am I supposed to use?
Yeah, I don't know. Exponential growth.
Oh, the law of exponential.
So the
Okay,
y,
go.
I
Let's
don't
go.
know what y is.
Y equals.
The
And
x is
Y equals what?
a will be
Just give-
100.
Well, give me your formula.
100.
Give me your formula. A.
E.
to the bx.
Oh, that's not right.
A times e.
Base AE
Whatever.
to the bx.
to the BX. That's your formula?
Yes.
Okay.
Okay.
And so what are you going to do?
So is A and B the number of flies?
Well, you have two different equations, right? So let's start with the first one. So after 2 days, so my B is is
Two.
your time.
Why does math hate me?
I'm sorry.
It's
Two,
out to get me.
your x is your time. That's your variable, right?
Yes, I thought it was, but you said B. I'm
So
like,
e times b to the, what did I say, 2? And it tells us there was 100 fruit flies.
it's two.
100 is the y. That's what it
Oh,
is,
it's
right?
in the book?
Based on x and y are your dependent and independent variables. So
Yeah.
x.
Wait.
If you have two days, there's 100 flies.
Okay, yeah, I get
Okay.
that. But what's A? And then what's B? There's two variables. We can't do this.
Why? You've never solved an equation with two variables?
See,
No.
this is like there's
Really?
6 variables.
You've
So
never.
y, a, b,
Well,
and
y
x
and
are
y and x
four.
aren't variables. Those are
Yes,
well.
they are.
Once you put them in,
Don't you lie.
you plug them in. Now all you have left to find is your a and b. But you can do this, right?
So
No.
then b is 4 days.
Oh, so then I got another equation, which is what? I'm sorry, what?
B is 4 days.
All right, so
And
300
a is 300.
equals a e b to the 4. Or 4. We should say. We should say
Before.
4.
No, I thought they go together. What?
What do you mean they go together? Those two separate equations, right?
But then how am I gonna solve for a and b?
And then we have to find what
You
5
tell me.
is. Yeah, no.
Okay, can't
You're
the
cheating.
4 isn't the 4?
Let's find what
equal
a
to
is first.
B?
Let's find what a is first. That's
We
important.
can't.
Let's,
We can't.
you
I can't
can't?
do it. Nope.
Of course you
Wait,
can.
put B as 0.
No,
No.
no, just slow down. Slow down. Think of it like this. What if I told you this? What if I told you x plus y equals 3, and I said 2x minus y equals 4? You could solve for x and y.
No.
Yes, right? You did that in algebra 1 and 2,
Oh, but
right?
see, that's so much more complicated.
That's so dumb.
That's ridiculous. I'm sick of this already.
So,
Are
let's
you
find out what
serious?
let's find out what a is first. So what is a?
Nothing.
Yes, it
Okay,
is.
well, you're
It's
gonna have to
100
divide-
over
Yeah.
e to the b.
And now you're telling
2b.
me to put that into the A on the other side to solve
Sure.
for B.
Yeah.
No, I refuse.
No.
100
I
equals
agree.
100 over e to the 2b
Now you're telling me to put that on the other.
to the 4b.
Are you okay, Kelly?
So now this is why you learn how to do solve these equations. So you can
You
solve
left
this for
out
b
E.
now, can't you?
You left out an E.
You left out me.
I did.
Yeah, you did.
Where?
It's A times E.
Oh,
Right? So it's,
yeah.
Don't
Yeah.
you do
Yep.
this.
Okay. So now what?
So.
No. Do we have to do it? We could not do it.
So we. No, I don't want to do that.
No.
Huh?
I don't want to do this.
Should you
I'm
multiply
scared.
the E? No, that's a bad idea. Just kidding. Don't do that.
Don't do that.
Oh.
Divide? No, don't do that either. We
You know, I
don't.
have no idea.
You know we don't know,
Okay.
and you know we're scared to do anything.
So-
I'm really pondering here. I'm really trying to figure this out, and it's just not happening.
Well, no, don't.
Okay.
Can we multiply the e in? I'm gonna take a stab in the dark.
You do that.
Maybe we should divide it by E to the 4th B. So that you get that on the other side.
You want to divide 300
I wanted to do that.
over,
No, yeah.
and then you want to have a
No,
b.
divide.
You want to have a b on both sides of the.
Wait, do we need to subtract 300?
Actually, no, I don't.
Subtract
I really don't.
300. Is
No,
that
because you have to get B by itself.
That would give you a
because it's
0.
variable.
it? Oh, it's not good.
Okay.
We don't know what to do.
You don't.
Are you surprised?
Can
What-
I cheat?
what
Press
if-
the button.
What if you
Yeah,
divide?
cheating.
What if you divide both sides by 100? What are you gonna get?
What do you,
Can
why?
you multiply?
What would you get?
How?
How can you divide it?
You can do, and we have an equation. Divide both sides by anything you want. You can divide by 12 if you want to.
That gets you 0 on top, doesn't it?
Huh?
What?
Divide by 100, not 300.
Yeah.
Equals-
You have
what's
to do
this
that to the other
divided?
side.
What's that?
Then you have to do it to the other side.
Right. What is that?
I don't know.
100 divided by 100 is 1.
Okay.
And then you
So
have.
it's 1 over
Well, it's
E
not.
to the.
I don't
3.
understand.
Lost my spot. Sorry.
Where's the book? I want to see this stuff.
It's just. Why does it have?
I'm so done with this.
One
I'm
over.
stupid.
How does it cancel? What?
How did I get?
Where did the.
Where did the other one go?
Hang on, slow down. Alright,
Why am I so dumb? How did I get to this?
so you have 300
How did I
equals.
Good math.
Yeah, how did I get to this math? That's how I want to know. I'm not smart enough to be here.
I hate when I use the same color because they start to run into each
Or
other.
not.
And I can't see it well.
Where did the e to the 4b go?
Yeah.
Where did it go?
Yeah.
Yes,
Where
where
did
did it go?
It disappeared.
It
What
was
do I do?
bye-bye. And it's gone. And I'm gonna cry. Oh, wait a minute. I know what it did. I actually know what happened. I think.
You have.
It divided, right? Because when you divide it by 100, you can multiply that in, and then you have E4b over E2b, and then divide it, you minus the things, right?
You might be right, but I didn't follow it. So tell me again. You have to say it a little
Okay, I think
slower.
I got you. So, if you divide by 100, then you have 1 over e to the 2b
Right.
times e to the 4b.
Right.
So you can put e to the 4b over e to the 2b, and in that case you subtract the exponents to get e to the 2b.
Yes.
Okay.
That's what I was trying to say, and it
I
didn't
just
work.
clarified that a little bit.
Okay.
Oh gosh.
So is it easy after this?
Yes.
So then it's equal to 3.
And then you do
It's
the
what?
ln.
3 equals e.
3?
300 over 100 is 3.
Okay. I left it as 300, but that's, yes, that would be correct.
ln.
What?
ln.
Yes, I didn't reduce it, but that's fine. I put it in the calculator 300 over 100, it came out the same, that's fine. ln 3 equals 2b.
Yeah. And then you divide by 2.
ln divided by 3 over 2 equals b. Well, you could find that.
That was ridiculous. I don't ever want to do that again.
So what is b?
This is so dumb. What is B? I don't know. I won't be able to find it.
Well, actually, let's not put it in a calculator. Let's solve it first.
Ow.
No.
Let's,
No.
let's use this for my b
No.
and go into my first equation, which was y equals. Oh,
Are you serious right now?
yeah, I may have a hard time seeing if I don't
You're
want to make a
joking, aren't you?
mistake here. 100
Equals.
over. Oh,
Wait, no.
sorry. Yeah,
It's just
yeah.
100, isn't it? Just 100.
All right. Sorry. 100 equals a
E
e.
to the ln. Oh, this is so dumb.
And then you could solve that. Do the homework. We'll go through some more tomorrow. We'll take some time on this section if you're having a hard time with it.
Please.
Please do.
But take your time and really try the homework.
Okay.
I'm gonna try it.